Hi everybody, today we're going to assemble a multi-sensory electronic learning board from scratch, and we're going to test it. Might be somewhat of a long video, but this will show you piece by piece how to solder the components to the board. Let me introduce you to the components. So, we got 4 10K ohm resistors, a 100 microfarad electrolytic capacitor, a 10 microfarad electrolytic capacitor, an infrared sensor, 14-pin socket, 8-pin socket, 555 timer, LM324 quad op amp IC, 48 pin headers, 2 header connectors or header shorters, power jack, 2N2222 NPN transistor, a momentary push button, 7805 5-volt regulator, 3mm red LED, LDR, light dependent resistor, microphone, 4 1K ohm resistors, 2 100K ohm variable resistors potentiometers. They are labeled 104 on the top near the turn screw. 2 50K ohm variable resistors potentiometers labeled 503 on the top side of the variable resistor. Vibration sensor, a 100K ohm resistor, 390 ohm resistor, magnetic reed switch, and the learning board. Now, one thing you might notice is on the side of the learning board there is an extra flap. You have the option of breaking that flap off. It's perforated, so you just need some pliers and gently wiggle away at them, and the flaps will fall off. I might do that, I might not, I might leave it for you to do that. So, in any case, what we're going to do is we're going to start with the resistors. Pardon my carelessness, guys. There's also 2 0.1 microfarad ceramic capacitors, and they are not polarized. The resistors are not polarized. They are easy to solder into place. You just need to look for the resistor slots, and you need to read the values on the footprints. In the case of R9, it's 1K, so you solder one of your 4 1K ohm resistors there. R6 is a 10K, R5 10K, R7 100K, R12 10K, R13 390 ohms, 390R. So that's your single 390 ohm resistor right there. R3 10K, R10 1K, R11 1K, R4 10K. So you just need to look around on the board for the resistor slots. They each footprint does have a number, like an R number, a resistor number, and a value. So they're actually really easy to solder into place. Remember, we've got 4 1K ohm resistors, 5 10K ohm resistors, a single 390 ohm resistor, and a single 100K ohm resistor. So find those areas, solder them into place. I'll show you what the board should look like in just a second. Time to populate the variable resistors. There are 2 50K and 2 100K. On the top of the variable resistors, you might not be able to see it there, but there's a little indicator. In this case, it's labeled W503, which is 50K. In this case, it's labeled W104, which is 100K. So, our 50K ohm variable resistors go in the VAR1 slot and the DLY slot, while the 2 100K ohm resistors go in the gain 1 and gain 2 slots. Now, the values are actually labeled underneath. But one thing to note, while the screw head on the PCB is on the right, on the footprint, there's a little screw head indicator. You want to make sure that when you solder it in, that the screw head is facing left in all 4 cases. And I say that because you can solder them in either way, but if you solder it in with the screw head facing left, then when you turn clockwise, in every case you turn either the gain up, the pulse width up on the 555 timer, or the voltage up on the variable resistor reference for VAR1. If that doesn't make any sense, you have to watch the other videos to see how we use these variable resistors in our projects. But in any case, make sure that you solder the variable resistors with the screw heads facing left in all 4 cases. So solder those into place, and we will do the capacitors next. Ceramic capacitors are easy because they don't have a polarity. They go in the C1 slot labeled C1 0.1U for 0.1 micro and C3 labeled C3 0.1 micro. Solder them into place. You don't have to worry about which way they go in. Now, another thing I forgot was the 220 microfarad electrolytic capacitor. And pardon me, that slipped. It's right in here. I forgot about that, labeled C7. And let's talk about the electrolytics. In every case, the electrolytic has a short lead and a long lead. The short lead is the negative, the long lead is the positive. In the case of C2, and pay very close attention here, you do not want to reverse the polarity of these. In the case of C2, on the lower lead from this perspective, you'll see a little plus sign just to the left of the bottom hole. And that is where your positive lead would go. So your 100 microfarad is right here. Long lead goes in the lower hole. Short lead goes in the top hole. Very, very, very important. If you power it up and you have that reversed, that will likely pop, or it will let out all the air, and it won't do its job, or it might cause an internal short. Make sure that the positive lead goes in the bottom hole, shorter lead goes in the top hole. In the case of R5, which is our 10 microfarad, our smallest one, and you can read the values on the sleeves. The 10 microfarad goes in the C6 slot right here, and there is a positive symbol on the right pin and a negative symbol on the left pin. Make sure that the long lead goes in the right hole and that your shorter pin goes in the left hole. If you reverse that, your 555 timer won't work properly. In the case of C7, the 220 micro, there is a little plus sign on the left, little negative sign on the right. So long lead goes in the left hole, short lead goes in the right hole. If you that's another capacitor used for your 555 timer. If you reverse that, your 555 timer will not work, and again, that capacitor might pop. So be very, very careful with those components. Once we're done with this, we're going to put in all of our headers. And our headers, it can be a little bit difficult, but it can also be kind of fun, so stay tuned. Using some wire cutters such as these, you can easily break up your large header down into smaller headers. Just be gentle. It's very easy to do. Don't use your fingers to break them apart. Use some nice little wire cutters. What you want to do is you want to break it down into 6 4-pin headers, 2 8-pin headers, 1 single-pin header, 2 2-pin headers, and 1 3-pin header. Now, soldering the pin headers can be a little bit tricky, but I'm going to show you a fun little trick. I've placed the 2 8-pin headers on the main pin block. I haven't soldered them yet. They are loose. Now I'm going to solder them together at the same time. And what I'm going to do is I'm going to take one of the 2-pin header connectors and I'm going to short right in the middle. And what that's going to do is that's going to allow me to hold it down while I turn it around and keep it flush to the board, and it's also going to make sure that they stay together. Now I can dab a little bit of solder on 1 pin here and 1 pin here, and once that's done I go back to make sure that it's nice and flush to the board, looks good. Then I can keep that header on and solder the rest of the pins, making sure that there are no shorts. Now that it's soldered into place, I can remove the header. Looks nice, huh? Now I can do the same thing for the sensor selection pin block right here, the comparator pin block, and the power supply pin block, using the jumper trick. Solder those into place using your 6 4-pin headers. And then lastly, we'll do the 3-pin headers, the 2-pin headers, or the 3-pin header, the 2-pin headers, and the 1-pin header. The first thing you're going to want to do is to take one of your headers and connect it to the sensor selection pin and block, just so that you don't lose it. Very important. Next, you want to solder in the PIR pin block, the 3-pin header connector right there, and you can use your remaining header connector right here to hold it down, and just so you protect your fingers from being burnt, because heat can travel up these pins and it can burn you. I typically use my nail, if I'm not using a header, to hold them down from one side like this. Anyway, back to it. The RPI jumper is located right here, right below the VAR1 variable resistor. So make sure you get the 2-pin header in there, and as soon as you're done, place the other 2-pin header connector on top of it, shorting it. Otherwise, if that RPI connector is not shorted, power will not reach the board. Very important. That jumper is for Raspberry Pi interface. If you want to learn more about that, please see the manual. The therm pin or header connector right here, the thermistor pin block right here, requires a 2-pin header, so solder that 2-pin header into place. And lastly, your single pin header. That is for the LED, and that goes in the LED pin right here. It's labeled LED on the board. It's one big pin. So solder that into place. Make sure it stands at 90 degrees straight up to make it look nice. Once we're done that, we're going to solder in our sockets and place our ICs. Both sockets and the ICs have a notch on the left. You want to make sure that when you place the sockets in first, that the notch on the sockets are facing left on the board. The socket for the LM324 has a notch on the footprint just to the left. You'll see it. You might have trouble seeing it from here, but the notch on the 8-pin socket, the 555 timer, there's a notch on the left. It's an indicator. So make sure that when you place it from a bird's eye view that the notches are facing left. Make sure that there are no shorts. If there are shorts, your circuits might not perform properly. Once you're done that, carefully place the ICs in the sockets with the notch facing left. Again, if you're careless and you place them facing the right, then you power it up and you'll likely fry your chips. So very, very important. Pay close attention to this. So solder them into place, the sockets, and make sure before you place the sockets in, or place the ICs in the sockets, that there are no shorts on the bottom. It is easy to short these, so be careful. The momentary push button only fits in one way, to the cell 1 slot. So line up the holes and carefully push it in. Make sure it's flush to the board before you solder it into place. Luckily, once you push it in, the leads should kind of clamp it down, so it's easy to solder. But make sure that once you soldered 1 or 2 leads, that you check to make sure that it's still flush with the board before soldering the other leads. Very important. The 2N2222 NPN transistor has a rounded side, the back side, and the front side is flat. The flat side has some writing on it. On the footprint, right here, labeled T1, there is a flat side of the footprint on the right and a curved side of the footprint on the back. Make sure that from a bird's eye view that you line up the flat side to the right and the curved side, the back side, to the left, and that you solder each pin correctly. Make sure there are no shorts. The power jack has 3 pins. It only fits in one way, and the front, where you plug in your AC adapter, should face the front. Now, when you're soldering that into place, apply little bits of solder on each of the 4 holes. Don't apply too much heat all at once, because if you overdo it, you might melt some of the plastic. So, little bit of solder on each hole. You don't need to fill in all of the gaps. You just need to make sure that the connection from the power jack is actually connected to each of the 3 holes. You know, make sure that you do a decent job, but don't overdo it. Don't apply too much heat. Be very careful with it. The 7805. The front side is black and has some writing on it. The back side, sorry, if that was out of screen, out of shot, the back side is white. And this actual back side is connected to common ground. Now on the footprint, labeled 7805, right behind the power jack, there's a white stripe on the back. You want to make sure that the white stripe on the back side is facing the RPI jumper. And the front side is facing the power jack, like so. So place that down into the board, and it won't go all the way in. It's not supposed to. And what I do is I typically bend one of the leads on the bottom, or 2, so that it stays into place, and then I solder the 3 pins. Now the middle pin is connected to ground, so it requires a bit more heat. Make absolutely sure when you're done soldering these into place and you cut the leads that there are no shorts, because if there are any shorts on here, it'll be either on the input and ground side or the output and ground side, and that will cause a direct short. Be very, very careful not to short any of these. If you do short them, I certainly hope you have a solder sucker or some copper desoldering wire to make sure that there are no shorts there, because if you plug it in, you can damage the 7805, you can damage your power supply. When we power it up for the first time, I'm going to give you a quick, I'm going to show you how to know automatically if there is a short, but you can also test with the multimeter. Both the light dependent resistor and the vibration sensor, we want to make sure that they sit a few millimeters above the board, even up to a half a centimeter above the board. You don't want to force them all the way down into the leads. The LDR goes here in the LDR slot. The sensor goes into the VIB slot right here. So when I'm done soldering those, I'll actually show you about how high I like to keep them above the board. The IR sensor, this is the front of the IR sensor. This is the back of the IR sensor. You want to make sure that the back of the IR sensor faces this side of the board and that the front of the sensor, the window as I call it, faces outward. And that goes right here in the IR slot. And so make sure that when you solder into place that the window is facing left and then the back of the sensor is facing right. So solder those into place, or if you wish, wait a quick second and I'll show you how I soldered in the vibration sensor and the LDR. The LED goes in the L1 slot. Now there's a short lead and a long lead. Long lead is positive, short lead is negative. And the L1 slot, you want to make sure that the long lead goes in the left hole and then the short lead goes in the right hole. Now that's very, very important. If you reverse it, your LED will not work. Long lead in the left, facing the IR sensor. Short lead in the right, facing the other sensors. Solder that into place, make sure there's no shorts, you can solder it right down onto the board. The magnetic reed switch is by far the most fragile component on this board, and you want to take very good care when pre-bending. If you bend this with your fingers, you'll break the glass on each side. Now if you even slightly break the glass on each side, your sensor will likely still work for a bit. I say likely. But there's a vacuum of air in there that you don't want to break, meaning that if you do break it, it might not last as long, and if you break it severely, it might not work at all. So what you want to do is take some very fine needle nose pliers, and I say very fine. Gently bring the tip up to the base of the glass, grasp tightly, and do a 90-degree bend. And you want to do that to both sides. Sorry if the focus isn't great here, I'm not using an autofocus camera. And you want to make sure that the bends line up with each other. Good. So when you're done that, you can place the reed switch in the reed switch holes and solder it into place. The microphone, the electret microphone, has two leads, and there is a polarity here, so pay close attention. One lead has three little traces on the back circuit board that lead to the outer casing, and that means that that is the ground side, and that's our mic minus side. We want to connect that side to the mic minus pin, and the other pin we want to connect to our mic positive pin. Make sure that the mic is a few millimeters above the board. Now just to show you what I mean about polarity here, I'm going to break out my multimeter and show you what I mean about the negative side. Sorry about the focus, I'm trying to focus in on the mic, not the multimeter. I've got my multimeter set to resistance, so if I touch the negative lead with the three little traces leading to the outer casing, and I connect to the outer casing, it shows that there's no resistance. So the negative lead is actually connected to the outer casing, which is ground. So that is our mic minus side. If I test the positive side to the outer casing, I get more than a kilo ohm of resistance. So make sure that you have the mic minus side connected to the ground side and your mic plus side connected to the positive side. Now we're going to do a series of tests. I'm going to take a female to female wire connection and connect to the DLY pin of the main pin block and connect the other side to the LED. Once I've done that, I'm going to power it up and I'm going to press the DLY button, and we're going to see if our 555 timer works properly. Plug it in, press the button, and it works. So now I can adjust the pulse width I can make the pulse width longer by turning this screw on the DLY potentiometer variable resistor clockwise and make it shorter by turning it counterclockwise. Let's test some of the sensors. First of all, you should have a little magnet that comes with it. So take out your magnet, put it aside for just 1 second, take a female to female wire connection, make sure that your mag pins on the sensor selection pin block are connected. Take the div 1 output and connect to the LED. By default should be high, and it works. We're still going to be using that div connection, so keep it there. But now let's connect VIB, the two VIB lines, and we'll reconnect to the LED. And the vibration sensor works properly. To test the LDR, short the two LDR lines on the sensor selection pin block. We've still got our female-to-female wire connection connected to div 1. You set your multimeter to voltage. Place one pin to the output of the LDR on div 1 and the other pin to ground. And then put your hand over the LDR. Is it giving you a different voltage? Sorry, I don't have a good connection here. There we go. And the LDR works. What I've done here is I've selected the microphone by shorting the MIC pins. I've taken the AC coupled output, labeled AC on the main pin block, connected that to the A1 plus pin, which is the input of our non-inverting amplifier, or one of our two non-inverting amplifiers, and I've taken the A1 out pin and connected it to the LED. The A1 out pin is the amplifier 1 output. So now we can tune sensitivity, but I can just yell into the mic right now, "Hello! Hello! Hello!" So the mic lights up a little bit. You probably can't see it. So the gain 1 variable resistor is right here. I'm just going to turn it clockwise a few times. Hello! 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 So it's lighting up a bit more. I'll up the gain a bit more. Hello! 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 There we go. So the microphone works. Hello, sir. How are you doing today? The microphone works. So we know that our LM324 IC is working properly. It is amplifying. You can do the same test if you'd like on by connecting the AC pin to the A2 plus input and taking the A2 out pin and connecting to the LED. And then you can adjust gain by adjusting the gain 2 plus variable resistor. And that will ensure that the second comparator is working, or second amplifier is working well. If you take the IR pin from the main pin block and connect it to the LED, it should light up because it's normally high output. It won't light up much because there's a lot of current limitation on the output of that sensor, but it will light up a bit. What I've done is I'll take my Rogers remote and I'll press the volume up key because that offers long pulse widths, and I'm going to aim it at the sensor. And I'm not sure if you can see it from here, how well you can see it, but it should flicker a few times. It should flicker lightly. And that tells you that it works. You can bring an oscilloscope to that output, but the best way to give it a quick, easy test is to use your remote control. Now, certain buttons have shorter pulse widths, and so you won't be able to pick up on the blinking, like where I am right now. But the volume plus key offers a visual blinking, so that works for me. I know that sensor is working properly. So now we have tested all of the sensors. We've tested the 555 timer. We've tested the amplifiers. We haven't tested amplifier number 2, but I've just told you how to do that. Let's test a comparator. For this test, I'm going to test both the variable resistor, the VAR 1 variable resistor, and a comparator. So what I'm going to do is I'm going to break out the multimeter again, place the black lead on the 7805, the back of the 7805, which is ground, and I'm going to test the VAR 2 pin, which is second from the bottom left, on the main pin block. Now I can't really do this very well with two hands, so what I'm going to do is I'm going to pull my screwdriver. It's sitting at 2.09 volts. I'm going to calibrate that close to 2.5 volts. And how I'm going to do that is I'm going to take a screwdriver, pardon me if you can't see this, I'm going to go to the VAR variable resistor and turn it clockwise a few times. Did it change? Yes, 2.8 volts. So the variable resistor is working. It's offering a variable voltage between 0 and 5 volts based on how you tune it. Turn the knob clockwise to turn the voltage up, turn it counterclockwise to turn the voltage down. Now that we've got that set to roughly 2.5 volts, we can test our comparator. The output of the 555 timer is normally low until we press the button, at which point the LED, if we had the DLY output connected to the LED, it would be low until you press the button, at which point it would go high for however long you've calibrated it for, and then would go low again. What if we wanted a normally high output? We wanted to invert it. Let's try one of our comparators. What we'll do is we'll take the DLY pin, the output of the 555 timer, and we'll connect it to a female-to-female connector, and we'll connect that to the negative pin of comparator 1 on the comparator pin block. We'll take our 2.5 volts from the VAR pin and connect it to the C1 plus pin on the comparator pin block. So basically we have more voltage on the positive pin of the comparator than we do on the negative pin until the output of the 555 timer changes. So now we just take the CP1A pin, the output of the first comparator, and we'll connect it to the LED, and the LED should be on. Now, if I press the button, the output goes low until the duration is done on the 555 timer, and it goes high again. So we've just used a comparator to invert logic. We can do the same test with the C2 minus and C2 plus pins, and then we would connect to CP2A, comparator 2A output, and connect that to the LED. So we've gone through the entire test of the board. You can test, there are 2 amplifiers and 2 comparators. We've tested one of each to save time. You can go through it on your own if you'd like. And now you're pretty much ready to go watch the product videos and the project videos. Always make sure to check out the schematic. If after you put your board together, you run into some problems, there is a troubleshooting manual in the, or troubleshooting section in the manual. And if you do run into problems, always check your soldering. Always check your soldering, and you should do that before you populate your ICs. But yeah, when I send out the fully assembled boards, I will have tested all of these myself before sending them out. One last thing. If your board comes with the side panels on it and you want to take them off, all you have to do is take a pair of needle nose and gently break it off. They're perforated edges. And there you go. The multi-sensor electronic learning board. Thanks for watching, everyone.